Sparking joy is a phrase made popular by Marie Kondo, who has recently become popular for her method of personal organization, the KonMari method, where she urges you to gather your personal belongings and ask the question, does this spark joy? If whatever you're asking doesn't spark joy, then you're meant to rid yourself of that earthly possession, keeping only the things that spark joy for you. The phrase has made its way into the product management world in an attempt to ensure that the products and features you deliver spark joy. But too often, we're concerned with sparking joy for our customers. We forget that our developers' experience and joy has a direct impact on the end product and customer happiness. We found that without an exception reporting tool, we were relying on customers' unhappiness to report issues in our web application. And by integrating exception reporting with distributed tracing, we could get ahead of any customer issues while improving our developers' experience. This is my story on how I was able to get engineers excited about observability tools by leveraging a production issue that got our engineers joyful about the future of debugging in our organization. My name is Zach Delagrange, and my preferred pronouns are he, him. I have been working with cybersecurity startups for the last 7 years, improving engineering quality with automation, including continuous integration, automated testing, release management, and observability. I cut my teeth on professional software engineering with browser automation with Selenium. Python is my daily driver, but I've worked on projects that include JavaScript and React, Java, Ruby, and Go. I really like the idea of robots informing developers of issues, since it's hard to have an argument with a robot, and I like being able to provide other engineers with informative and transparent metrics to help them make better decisions. Lately, I've been working with Area 1 Security, helping to mitigate the most common breach vector, phishing. Before the story begins, I'll need to talk about how mature our observability toolchain was at the start of this journey. I've included the logos of some tools that could be used for the exception monitoring and distributed tracing space. We had implemented an exception reporting solution specifically for our front-end application. Exception reporting for a browser client is very helpful in squashing regressions and catching bugs. The code runs on machines out of our control, and this gave our engineers insight into exceptions occurring in real time across different environments. The last thing we wanted was for a customer to run into a bug in the wild, close their browser out of frustration without even reporting the issue to us, losing faith in our product. This was a great addition to our tool belt, but often it left the engineers wanting more. They would have to dive into our logging solution and wade through a swamp of logs, hoping that they were looking in the right place. This was a cumbersome task that didn't have the best user experience. Learning how to filter through the logs to remove the noise was like trying to find a needle in the haystack. And with our distributed infrastructure, our engineers didn't always know which systems were involved in the specific operation that ignited the exception alert. At this point, I was working on solving that problem with a distributed tracing solution and was wrapping up the proof of concept phase, and I needed to find a way to get the team excited about it. I wanted our engineers to have faith that I could provide them a solution to the doldrums of wading through logs. We had observed a small number of exceptions occurring in our exception reporting tool. It seemed that a timeout was occurring on a specific endpoint. This specific endpoint's purpose is to deliver an asset to our customers in 2 different formats. One as a raw markup file that our customer would download and do as they wish, while the other format was a rendered image of the markup to be viewed in the customer's browser. Due to the stringent data security practices and policies, we were not able to easily reproduce this issue. We weren't able to make the same request as the customer without jumping through some hoops, and all of our attempts to reproduce the issue failed since our test environment did not contain the same data set as production. So after some diligence, it was decided that we would deprioritize the issue since it seemed like the surface area was pretty low. Things can start to get hot once an issue crosses organizational barriers. In this case, a high-value customer has called into the customer success team which initiated the incident response in the form of a ticket in our issue tracker. Due to the nature of our organizational structure with distributed systems, this meant that we had to embark on a distributed debugging adventure. In this specific case, the ticket was assigned to the team that owned the service that fetched and delivered the asset to the client web browser. This specific service and feature were in use in multiple applications, and the context of the debugging was from the perspective of the service owner. Because of this, we assumed that the end user just needed to twiddle the timeout feature that was already implemented. But that didn't solve the problem. The end user didn't have access to this feature from their entry point. The timeout was occurring on a load balancer with a reasonable timeout set for a web application, while other internal entry points to this feature were able to modify that timeout as they saw fit. As the surface area of the customer issue mutated as we were analyzing it, more engineers were brought in to assist on the solution. Since this particular issue was for a VIP customer, we brought in the high-value engineers who were knee-deep in domain knowledge of their respective services. These were the people who built their respective products and services from the ground up and were acting as tech leads towards maintenance and new development. Back and forth occurred on the ticket, as well as some private communications between engineers trying to figure out where the issue was. On one end, the feature was working as expected, and on the other, we thought we were using the API appropriately. The root of the problem was eventually unearthed as a missing query parameter after 5 days of debugging. So we had a long, stressful experience coming to this fix. If you've worked on a team with distributed systems before, you've probably run into a situation like this. We had engineers working in good faith, attempting to find the root cause of the issue, each having a high level of knowledge in their respective systems, but knowledge of the integration points were muddled. For the most part, things were working, except for this one specific query. From ticket creation to release, it took us 5 days to implement the fix. We had all of the continuous integration and delivery infrastructure available to us to release bug fixes quickly, but the question lingered in the air was, how do we find these bugs quicker so that we can take advantage of having a mature continuous integration process? The long time to fix had repercussions. Engineers weren't working on the interesting tasks that keep them happy on a day-to-day basis, and they were losing time towards completing their commitments. We had a high-value customer waiting for a fix, when shorter time to fixes could instill higher trust and create an atmosphere where they felt like their needs and adverse experiences were being addressed quickly. Once we were able to easily reproduce this issue, I thought that it would be a great candidate to build excitement about distributed tracing. It hit all the marks to pique the interest on multiple levels of the engineering team. The issue drove the development of the tracing instrumentation. With a real problem at my fingertips, I could find a way to capture important aspects of a trace to quickly demonstrate value of the tool. I was able to demonstrate the whole transaction through our services and deliberately show that we capture query string arguments. The aha moment happened. This is where the engineers close to the problem realized that if only they had more context in the problem, like services involved, environment details, and relevant variable values, they could save a good amount of time coming to the solution. Engineers want to have more visibility into the service landscape. More information at their fingertips allows them to have informed conversations. We spent a lot of high talent time coming to a fix. The management side of the room realized that they could have saved hours by assigning less resources to the problem at the start, which will allow their teams to focus on delivering their commitments instead of working on ad hoc tasks. When I presented the tool to the relevant stakeholders of this particular issue, the reactions were those of delight. I demonstrated that with distributed tracing and exception reporting, we could use the information to not only get a head start before the customer reports an issue, but we could also save their time and energy towards driving their own projects. And engineers didn't have to learn how to filter through different logging solutions. So after the POC phase, as we were preparing the infrastructure for the release of our tracing solution, I started to receive direct messages from peers asking when they could start using these tools. They were excited about it, and they were asking when it would be delivered. There are some technical details required in order to correlate an exception found in our exception reporting solution with a trace. Because I'm focused on our customer-facing browser application, it's difficult to record spans to our internal distributed tracing tool. We don't want to expose our distributed tracing infrastructure to the public to reduce the possibility of falling victim to a nefarious actor. Not only does access to our customer data fall under our compliance umbrella, as a security company, falling victim to a breach would open up a can of worms and call into question our security prowess. Not only that, but I found that the browser client integration for web applications for distributed tracing hasn't been fully realized yet. There's a little bit of work that needs to happen in that space. So each span contains a trace ID, which is the unique ID of the whole trace as per the W3C trace context specification. We can't technically start the trace in the browser, so we work around this by passing a conversation header to all of our services' outbound requests, including from the browser client. We then use that header to add a tag to our exception reporting tool and to our distributed traces. When an event gets reported to our exception reporting solution, the tagged conversation header is easily visible and can then be transferred into our distributed tracing query engine. Since that ID is also a tag attached to a specific trace, we can then view the complete trace across all of our services. This is also where it pays to be diligent about how you instrument your services with distributed tracing. Try to use a real issue to guide your instrumentation. Try to create clear transaction boundaries and add relevant baggage to your traces can be really important. Try to understand what's important to the issue and to the service. If you're reporting a database transaction, is the database query important? Does that query have a name or parameters that you can add to the trace? And don't forget one of the hardest problems in computer science, naming. Good naming for your spans is really hard, but they can go a long way towards tool adoption if you can get it right. Try to understand the team's domain dictionary. If they use abbreviations a lot, try to spell them out explicitly so someone not so familiar with the product can dive in easily and help contribute to a fix. It's easy to get caught up trying to think about what could be important. I try to allow my instrumentation to evolve as new issues crop up, and I try to learn from issues that seem to have difficult root cause analysis. Like all software, it will never be perfect, but by being detail-oriented, you can allow it to mutate into a powerful asset. Thank you very much for your time. Are there any questions?